Okay, so let's continue with PH 110, and our topic that we are discussing is force and motion. In the previous video, we were talking about some forces in nature. So we continue with one more important force in nature, which is friction. What do you understand by the term friction? So friction can be defined as a force that is around us all the time that opposes relative motion between systems in contact, but also allows movement or motion, or it allows us to move. Okay, so it is the force that opposes motion. All right, and we are going to talk about two basic types of friction. The first one will be static friction, and the second one will be kinetic friction. Static friction will be a friction, the kind of friction that will be experienced for something that is stationary, while kinetic friction will be a kind of friction that will be experienced between moving objects. Okay. Now, even before we talk more about the types of friction, we are going to talk about some laws that governs friction. And the first law is the friction of the moving object is direct proportion and perpendicular to the normal force. So this is our first law. What this means is friction is proportion to normal force. And when we put our equal sign there, we're going to have the proportionality constant times the normal force. Now, the proportionality constant is what we are calling as the coefficient of friction. Okay, the coefficient of friction, and it can be denoted by mu. Okay, so now our formula for friction becomes friction is equal to mu times n. So this is our formula for friction, where mu is the coefficient of friction, n is normal force. Right, let's move on. The second law states that friction experienced by the object is dependent on the nature of surface it is in contact with. So we can have a surface that is a rough surface or a smooth surface. So friction would depend on the surface. Okay. Then the third law says that friction is independent of the area of contact as long as there is area of contact. Then the fourth law states that kinetic friction is independent of velocity. Then the last law states that coefficient of static friction is greater than the coefficient of kinetic friction. What they are meaning here is the mu, okay, saying that the mu of static friction is greater than the mu of kinetic friction. This is true, okay, because the mu or the coefficient of static friction is when the object is stationary, it is not moving. But this one is when the object is in motion. Okay. So this one that is making the body not to move will be greater than the one that is causing the body to what? To move. Okay. Now let's talk about static friction, the first type of friction. Static friction can be defined as a force that opposes the motion of two systems that are in contact and are not moving relative to one another. In other words, it is the force of friction between two surfaces before relative motion. Okay, let's see this illustration here. For instance, you have a block, okay, and you put it on a surface, let's say a rough surface, okay. And when you put this block on a surface, this block has some weight that acts downward. Okay, due to this weight, the ground will exert an equal but opposite force. Okay, that will be upward force. This will be our normal force. Now, if we are putting this block by, let's say, force F, okay, we are putting this block by force F, this block will experience some friction that will be in opposite direction. Now, since this block is not moving, we have what? Static friction. What this means is, since this block is not moving, the pulling force is equal to static friction. Okay, but we know that our static friction from the formula of friction is what? Mu n. Now, mu, since we are dealing with static friction, will be mu s, the coefficient of static friction multiplied by normal force. So this would be our formula for what? For friction. Okay, let's move on to another type of friction, which is kinetic friction. If two systems are in contact and are moving relative to one another, then the friction between them is called kinetic friction. Okay, we have a block here. It rests on a rough surface. It has some weight that is acting downward. Then the ground will produce an equal but opposite force that will be upward, which is a normal force. Okay, and then we are pulling this block by force F. Okay, but we have some motion. Okay, we have some motion. This object is not it is not stationary, it is moving. Okay, then this block will experience some friction, which will be in opposite direction. Now this friction will be kinetic friction since we have some motion. The object is what? Accelerating. Therefore, the pulling force is not equal to the kinetic friction since we have some motion. Okay, this implies that the pulling force is greater than what? Kinetic friction. Okay, but now we know what kinetic friction is from the formula of friction. Kinetic friction will be mu n. Now, since we're dealing with kinetic friction, it will be mu k. Okay, the coefficient of kinetic friction multiplied by normal force. Okay, so this will be our formula for what? For kinetic friction. Right. We have come to the end of our video. In the next video, we are going to discuss more about force and motion. See you in the next video.